So with this, we'll move on to the next session. I think Dr. Chandra Prakash has already joined. Sir, are you there?
Good
Yeah,
evening.
sir has
Am I
joined.
audible?
Yes, sir. Yes, sir, you are audible. Thank you so much, sir, for joining. So before we'll start, I'll give you a brief intro of Dr. Chandra Prakash. Dr. Chandra Prakash is a scientist and researcher at the Space Application Center, Indian Space Research Organization, ISRO, where he currently serves as a scientist engineer G and leads the satellite communication technology development activities. With over 25 years of development experience in satellite communication technologies, he has made pioneering contributions to national level projects in both the strategic and societal domains. Dr. Prakash has been instrumental in architecting and executing major technological development initiatives of the mobile satellite service-based asset tracking applications such as Vessel Communication Support System, also known as VCSS, for monitoring, controls, and surveillance, enabling real-time monitoring and emergency communication for over 1 lakh vessels across the Indian coastal states. Real-time train information system (RTIS) for Indian Railways, covering more than 8,000 locomotives. Technology for NAVIC-enabled real-time aircraft tracking system. As a project director of VCSS project, he led the national rollout of the network across all the coastal states and UTs. As the associate project director for the special user project, he has successfully led the indigenous design and development of India's first VSAT based systems and software for maritime aero ground communication networks with advanced transect features. His innovative contribution spans domains such as advanced receiver for space-based automatic identification system, ADS-B systems, NB-IoT implementation and waveform development for non-terrestrial 6G networks, software-defined radios for airborne applications, quantum communication electronics, and Gaganyaan crew communication system. Dr. Prakash holds a PhD in wireless communication MTech from ISC Bangalore and a BE from BIT Misra. He has completed the prestigious in-campus management and leadership development program at IIM Bangalore in 2024. He is a governing council member of Bharat 6G Alliance and has authored more than 25 technical papers and received several honors, including Nina Saxena Excellence in Technology Award 2025, awarded by IIT Kharagpur, ISRO Young Scientist Merit Award, ASA Team Excellence Award, and multiple ISRO Team Excellence Awards. Recognized for his technical leadership, innovation, and commitment to the national development, Dr. Prakash continues to drive the frontiers of technology for space-based communication and navigation applications, leading to the development of advanced satellite systems designed in India. With this profile, I welcome you, sir. You can please share your screen and we can start with this session.
Yeah. Thank you, Pankaj. I'll start sharing. Thank you for this introduction. It's a long introduction you have given. I wish you could have summarized it in 2 lines, saying that I've been
My
working
pleasure.
for a space application center in the field of satellite communication and technology. That's my core expertise. Of course, while doing that, I have been serving different user community, and that is my passion. To solve a problem of a user community, be it a societal user or be it a strategic user. And so let's start the session. I hope I am audible to everybody.
Yes, sir, you are audible.
Yeah.
Your screen is
So
also visible. That's fine.
yeah. So if you happen to have some questions in between, please feel free to interrupt, or otherwise keep it reserved. Towards the end, we will have it. Let me start by saying that is space-based communication and navigation is now all pervasive. It is in everybody's life, and quite often it is invisible. Uh, Today's session is basically on a space-based communication and navigation, and I just try to outline some of the problems which are where AI and ML could be a good tool to solve it. I'm not a domain expert for AI and ML, but with my experience of working with user community and in this domain, uh, I understand that what set of problems which you can address efficiently using this tool called AI and ML. So I'll try to highlight those aspects during my presentation, but it will be primarily based on how the space-based communication and navigation is going to look in the next era. So I'll start with initially, like now this is, you all must have been aware, these are all available, but just wanted to say that India started it as it's a space program with only objective of harnessing the space technology for societal benefit. Our what you call it is the founder Vikram Sarabhai, he said is we must be second to none in the application of advanced technology to solve the problem of man and society. However, today we have graduated to an era where a space is no longer being utilized only for societal benefit, but it has become a strategic asset. So, as I said, is like now we started with a very modest beginning. In 1981, we had our first satellite, and now we have gradually moved to like now we are holding 6 orbital locations in space, which is reserved for the country. This is an old satellite, old slide. I will touch upon the recent ones, but we have more than 250 transponders serving in different frequency bands and serving in different areas. This is just one slide to give you that how this has grown from a simple societal experiment, which has started with a satellite instructional television experiment, to become a backbone of national communication need and a strategic communication need as well. So when you talk about the communication payload, India now has got payloads starting from UHF band, S band, C band to Q and V band. And now, in fact, we have a satellite in optical for optical communication as well. And very soon we are going to have a satellite, basically opto-quantum satellite, where we are going to demonstrate the quantum communication from space. Why that we'll touch upon later on, but these are set of satellites. At the same time, you all must be aware that the denial of service is something which is going to be challenging for any country which is fighting like now for its existence in today's world. We all are surrounded by so many wars happening here and there. So you cannot give control of all your arms and ammunition, or basically the navigation and guidance control of your artillery in the hands of somebody else if it is dependent on just a space-based navigation. So it is far more imperative to have our own navigational satellite system, and that's how India started IRNSS. Earlier it used to be called Indian Regional Navigation Satellite System, which was primarily meant with 7 satellites, but now we have graduated, we call it NAVIC, and very soon this constellation is going to complete. We lost some of the satellite in between because of one of the failures of the atomic clock, which was a procured item. It took us some time to build it indigenously, but I'm happy to share with all of you that India happens to be now self-reliant in terms of building these atomic clocks, and very soon we are going to have this our own navigation system, satellite system operational. We have also built, meanwhile in the interim, we have also built a augmentation system, space-based augmentation system called Gagan, which actually helps us to determine the integrity of GPS while it is being used in the domains of civil aviation. So basically Gagan helps us to find out that whether the signals which are being relayed by these GPS satellites, they are really that they are authenticated signal, they are the real signal, they are not spoofed. So the integrity of that satellite, like now using a set of ground stations, we are able to determine the integrity of that satellite signals being received. So the best part of Gagan is it provides integrity, and it also helps us to take care of some of the scintillation like no effects by providing some of the grid corrections. So better positioning and integrity is something which is being determined by Gagan. this is one slide primarily for all those people who are working or who wish to work in this domain. I just wanted to list that not only the commercial domain applications, but government applications, be it for national security, be it for disaster management, be it for remote sensing data collection, for border surveillance, or for monitoring, or for navigation. All these, like no, these systems or these applications call for space-based systems, and they ultimately translate to different kind of satellite architectures, be it multi-beam payloads, be it hosted payloads, be it flexible architecture of satellite, or be it a navigation constellation. And nowadays you all must be aware that there are so many LEO-based high throughput satellite constellations are coming up, like a Starlink is there, OneWeb is there. They are coming up. While these things are coming up, Blue Walker is one of the company which has come up with the LEO mobile satellite direct to device connectivity, that is also coming up. So how these domains are flourishing and how India as a country is approaching this, I'll try to give you a glimpse of that in the next few slides. But before, on the commercial side of it, as you say that, like no, nowadays there are like no, the data requirements are gradually increasing from earlier from kilobit to megabit, now to gigabit, and people want data everywhere all the time. So that brings us development of 4G, 5G, and now India is trying to build its own 6G stack. So while doing this, going from 4G, 5G to 6G and trying to exploit the higher frequency band for terrestrial communication, the cell size are going to become narrower and narrower, and that puts more burden on building the infrastructure. They are not going to be very cost competitive. So satellite or other non-terrestrial network elements are going to play a major role in order to meet the peak demand of this country. So how that 5G and 6G are going to be like no, NTN is going to play a role in 5G and 6G rollout, that also we will discuss. So I'll take one by one. And what I'll do is, first part of presentation I'll introduce about the whole framework, and then I'll talk about how, like no, this AIML techniques could be utilized in this. So if you talk about the current activities, like no, this is all which we discussed, but there are very specific applications, like all these commercial aircrafts you see, they keep on broadcasting signal called ADS-B, Automatic Dependence Surveillance Broadcast. So they keep on sending their reporter. On flight radar, you are able to see the, say, like no, where the aircraft is, when it is going to land, what is the ID and all. Now there is a greater need because the ground networks are not ubiquitous. So problem is there are 60 or 70% of the area still is not covered. And there we are right now like leaving it with interpolated data sets. So a space-based ADS-B is one of the technology which is very popular nowadays, and India is also trying to build its space-based ADS-B. Now you talk about any of these communication systems, I will later on touch upon that you are going to have a role of artificial intelligence and machine learning techniques. Now, just to highlight one of the very good examples is I'll talk about is nowadays there is a flexible software defined radio payload design. What is this payload does is it is on demand, it is able to save the beam, it is able to route the traffic, it is able to route the power, and at the same time it uses very intelligent algorithms on board, which could be AIML based, to predict the interference, the pattern of interference, because many a times which we find that there are rogue transmitters which are purposefully being deployed for you to interfere your communication network. So to identify those interference also, there are AIML techniques which are required. I'll touch upon this in subsequent slide. Now, to meet the country's demand, there is a greater need, we call it high throughput satellite systems. What does this high throughput satellite system means is, now the spectrum is very limited. But now using the same limited spectrum, how like you can generate or maximize the throughput. So per bit per hertz, how you can optimize that, how maximum number of bits per hertz you are able to derive. One way which all of you are aware that use a higher order of modulation and coding. Because of the satellite system design, the higher order of modulation and coding going for like no QAM and kind of stuff, that is not feasible in satellite communication, primarily because of the reasons of PAPR, peak average to power ratio. Now problem is, so one way that having building a new kind of modulation schemes or optimizing the transmit chain or communication chain to derive maximum bits per hertz. Another way is like no, that is true for a particular beam, a particular carrier or particular transmission channel. However, if you see the overall like no bandwidth, and if you have done the channelization, how those channels can be utilized by providing like no within the satellite networks. Earlier the concept was in traditional satellite communication, the whole country was kind of like into one single beam, was covered in traditional satellite a single beam. Now in high throughput satellite, what happens is we utilize a bigger reflector and generate multiple beams. And if you see on the right hand side the HTS configuration, all those green dots will utilize one frequency, all those blue dots will utilize, blue beams will utilize one frequency. Frequency reuse, polarization reuse. So these are the new technological changes which has been done to derive the maximum throughput with the available spectrum in the high throughput category. And that's how this technology has become very popular. So geo-based high throughput satellites, if you will talk about, they are essentially needed because the user demand has now, if you, this is from internet which has been taken up, just to say that, am I audible? Hello.
Yes, sir. Please continue. Actually, there's some interruption. I'll mute him.
Yeah. So what is happening is, if you see the globally, the broadband access is increasing, ever increasing. The speeds requirement is also increasing. So it is very difficult to meet the conventional 36 megahertz transponders. So now we have increased the transponder bandwidth also to 125 megahertz, kind of, that has become a kind of de facto band, and then started reusing the frequency and polarization, making a multi-beam satellites to derive maximum throughput. So now, with respect to earlier traditional satellite used to offer 1 to 2 gigabits kind of throughput, now we are able to generate a terabits kind of throughput. And that's how the global like trend in high throughput satellites are coming up. So IP-STAR was the first in that category. And now in third generation, which we call it basically really a high throughput satellite, here we have written ultra high throughput satellite is Viasat-3, which actually is able to generate 1 terabits per second kind of throughput. And with 3 satellites, it covers all the part of the globe and provide this connectivity. But what is the challenge in this is, you have 3 satellites all in geo orbit. So the latency becomes one of the big problems. So how to deal with it, that we will discuss later. But coming back to the high throughput satellite, ISRO launched our own, India launched our own high throughput satellite called GSAT-11, which was actually 16 spot beams, 8 spot beams in one polarization and 8 spot beams in another polarization. And because of the spectrum only, there is a feeder link is in Ka band and user link is in Ku band. So all the VSATs are operating in Ku band, and all the feeder link, the ABA stations, are in Ka band. And there were 4 interconnected gateways, north, east, west, south. So they were interconnected and supporting, we were able to derive 16 gigabits throughput. I'm happy to say that it has been serving for last 5 years and connecting to all Andaman, Nicobar and northeastern traffic significantly. Recently, last year, we launched our another high throughput satellite. In between, there was GSAT-19 also available. However, we have gone to GSAT-20, which is a first car cross car satellite in this country, and it is able to give more than 60 Gbps kind of throughput. And this has got 32 user beams and 4 earth stations. So just to highlight that it is a 50 times more throughput than a conventional old generation satellites. So that's the kind of uh, improvement we are talking about, and it's falls in 6-ton class of satellite. So now we have started working on very high throughput satellites where we are trying to exploit the higher frequency band, Q and V band for hub links and Ka band for user link. And this is in making, where we are going to have more than 200 spot beams. Each beam will have a kind of 100-kilometer diameter, and that's the kind of satellite which we are talking about. So to meet the demand, still all this still is not sufficient. The way the user demand is increasing now, this is not going to be sufficient. Besides that, the latency in geo orbit is going to play a major role. So I will touch upon these two aspects, how we are going to deal with it in subsequent slide. This is one very important thing which I wanted to highlight, and which is everybody to understand, that now we are gradually moving towards a fully flexible payload architecture. When I say fully flexible payload architecture means, earlier we discussed that whole India was covered in one beam, then we went into multiple spot beams. Now the need is, like, if you see this, if you have all the beams circular of the same size, it may so happen that India is geographically such a vast country, a population at many places very sparse. So what will happen is, some beam will have more traffic, urban area, covering the urban area will have more traffic, and some beams which is covering a remote area will not have less traffic. But if we assign the same bandwidth and same power to each beam, it is not going to serve our purpose. It will result into inefficient utilization of power as well as a spectrum. So now the onboard payloads are to be fully flexible. So we should be able to route the power as per demand and the bandwidth as per demand. So that brings us to a new satellite configuration called a fully flexible SDR payload, wherein we are able to change the bandwidth of a particular beam, the power transmitted into a beam, even G by T of the beam can be saved, and then onboard channelization. Like now, earlier, the how we used to do is, you have a 10 megahertz bandwidth, and if you want to have a channel of 1 megahertz, you can't have 10 channels. You have to have 1 megahertz, then you have to give guard band of say 100 kilohertz, then another 1 megahertz, then 100 kilohertz guard band, and likewise, like now, you used to accommodate hardly 9 channels. Okay. But now with the transparent bandwidth processing on board, the signal processing technique, we can have all the 10 megahertz, 1 megahertz channel of 10 such channels can be accommodated. So it has reduced the need of the guard bands also. Similarly, beam steering. So beams are not beams are not even fixed beams. Even these beams you can steer it, and that brings us to the notion of a satellite which is not only the bandwidth, not only the power, beam could be steered, the bandwidth could be transparently processed, bandwidth could be channelized as per will, and routing could also be achieved. So this is something which we are working on. And here also, let me put it this before I move to the next slide, that lot of AI ML algorithms people are trying across the globe to implement on board. How this traffic routing should happen? Are we able to predict a traffic based on this is geo satellite? Then you know that fixed traffic patterns are known to you. But at a given day of the time, suppose the traffic is going to increase, or you are aware that it is going to increase. So in an autonomous fashion, that bandwidth could be increased, the power to that particular beam could be increased, and the resources could be reallocated. Routings, again, traffic routing. In some cases, the priority of the routing has to happen. In case of war, the traffic routings are prioritized. So that also could be achieved. So there are many such example applications of AIML are there. I'll touch upon them, some of them toward the end. This is a Eutelsat satellite Quantum, which I wanted to say because this is a practically which is in orbit satellite. Quantum doesn't mean that it is a quantum communication satellite. It is just a quantum jump. It is the next generation satellite, wherein this satellite has got 8 beams and dynamic coverage. If you see those 4 figures, which I have borrowed from there and taken up. So by reconfiguring, you can have a wide beam, you can have narrow beams, spot beams, you can have time wise 2 different beams or 4 beams or 8 beams. These beam shapes can happen based on traffic. You can, in fact, you can dedicate for a strategic purpose, you can form a narrow beam which can move along with the target. If you have to provide a aeromobile communication along with your target, this beam can also keep moving. So that's the kind of autonomy which people are talking about. And it's not only on paper, it is a reality today. It is operational from in orbit. It is covering the large geographical region of West Africa and in fact some part of Asia also. So this is the type of thing which we are talking about. That brings me, all that is fine. So technically we have achieved, but what we are not able to circumvent with geosatellite is the delays. So the delay, the problem is the propagation delays are going to be large, of the order of 125 millisecond, 250 milliseconds in cases. So how to do that? So that brings us to the next topic, which we call it LEO broadband satellite communication or LEO high throughput satellite. So which is basically the moment you come back from GEO to LEO, you require a constellation of satellites. So that's how this topic is in front of us, and we know that there are many operational solutions available. One is OneWeb. OneWeb is there, which is already operational in India for B2B users, and Starlink is for B2C. Very soon it is going to be serving the customers. So the benefit of LEO constellation is it reduces the propagation delay to 10 to 50 milliseconds, of the order of that. It also, since this is a 1000, starting from 600 kilometer to 1200 kilometer orbit, the path losses are going to be very minimal. So that brings down our terminal size. If we keep same or reduce the terminal size a little bit and go for 0.6 meter kind of terminal, the data rates which you are able to achieve is quite high, of 100 to 200 to even 1 gigabit kind of downlink speed you will be able to achieve, depending on which satellite you are talking about or which constellation you are talking about. And this is now this particular aspect is the user terminals. When we talk about these user terminals are all nowadays, there's a lot of innovation which has gone in place, and all these ground terminals are nowadays moved to planar antenna array system, and I am happy to share that a lot of these ground user terminals deploy a lot of AIML algorithms today in order to tackle some of the practical problems which we will discuss subsequently. So then there is another way is this satellites, LEO broadband satellite communication, the lot of onboard autonomy is there. Onboard autonomy because these satellites are going to be visible on ground only for 6 minutes. Typically 6 minutes is the visibility duration for one satellite. So one satellite goes out of visibility, another satellite comes in. So there is a lot of traffic routing needs to be done in order to, because user terminals always have to it should be a kind of continuous communication. You cannot have a break in the communication. So there is a lot of traffic handover mechanism and traffic routing needs to be done. So I will get into the specific elements where we can utilize this AIML subsequently if time permits. Otherwise, just wanted to appraise you that you have to how this satellite scheduling can be done, or how this terminal determines the satellite schedule, which satellite you should transmit to, to achieve the best signal conditions is also based on algorithms which is derived from AI/ML techniques. So there is a greater need of understanding the system architecture and then applying these techniques. So uh, in this small time of 1 hour, it is very difficult to explain the overall service architecture. But just to tell you that one satellite in Leo constellation is typically the visibility of 6 minutes, and there is a concept called make before break. So before the one satellite goes out of visibility of a user terminal, it makes connectivity with the other satellites. And all these satellites, which satellite to make connectivity scheduling, all this autonomously done by the user segment. At the same time, on the hub side, on the ground segment side, routing the traffic from one satellite to other based on the user demand, that also is being handled dynamically, and that is where all these algorithms comes in play. So there are a lot of challenges which I have, realization challenges I have listed, but it is primarily for people who wish to get into this, and each one of them is a topic in itself. One of them, just to tell you that GSO and NGSO coexistence, it is itself is a very big challenge. Okay, a big challenge means like what happens is when the satellite, Leo satellite crosses the geo arc, they also use Ku band frequency, and geo satellite in geo orbit also use Ku band frequencies. So how they can utilize the same frequency when they are crossing the geo arc without causing interference to one another? There is a OneWeb uses a technology called progressive pitch. So it tilts the satellite, like no, it steers the satellite when it is away from the geo arc, and when it comes over geo arc, it doesn't use that particular frequency in the satellite which is over the geo arc. So there are many ways to do it. One of the ways which I have highlighted. Similarly, transponder stealing is one of these big problem in these Leo satellites from a security perspective. So somebody can transmit and simply receive it utilizing your own bandwidth. So that how you can protect that. So these are all our technical challenges. We can discuss about it at some leisure time, or whoever interested, we can get in touch subsequently. Just wanted to give you an idea that, like you see, different constellation comes with different number of satellites, and these are a function of the altitude at which satellites are launched and the type of service which they are going to give. I will not dwell much upon this, because the reason being that is those who want to make their constellation global and offer services to every part of the world, they have to go for a larger constellation of the size of 4,000 or 10,000 satellites, which a Starlink is going up. There are people who have got regional ambition, or those who are only catering to a particular segment, like B2B. I used the word B2B. So OneWeb is B2B. That's how they are able to manage with 650 satellites only. And likewise, India also has started sample constellation we have designed, which will have a 140 satellites at 1200 kilometer orbit, high altitude, with 37-degree inclination. And we have just started as a technology demonstration, and just wanted to tell you that the constellation is designed in such a way that at any part of India, at least one satellite will be visible at all the time. So this is some of the thing, the development which has happened. We can discuss about this development subsequently whenever at a suitable occasion. If some questions are there, I'll try to answer, but this is primarily saying that this is a very small satellite which we are building in, and the design philosophy here is to utilize either mill grade components, or they call it commercial space grade, CSH, commercial space grade, high, low, and medium, CSL, CSM, that kind of grade components, so that the cost of the overall satellite becomes less, and the life of satellite generally in Leo orbit is only 5 years. The design philosophy is entirely to have a printable satellite, unlike that in geo, where we go for building ample redundancy and think of a satellite having 15 years lifespan. So that's a digression from there. There is another diverging trend in Leo constellation. I'm not too sure how far you all are appraised, but there is a AST Mobile has already come up with a satellite called Blue Walker 3, which has got a 64 meter square antenna in space, 9.6 meter by 7.6 meter, I understand, or 7.5 meter. That kind of antenna, which generates more than 230 spot beams, and each of these spot beams on ground is like one cell, one cellular cell, mobile cell, and they are at a height of 600 kilometer, and they are directly able to connect to a conventional smartphone and able to provide a mobile connectivity for voice and data. Okay, so this is another era where we call it direct to cell satellite system or direct to device connectivity also. So Blue Walker, Link Mobile, these are the companies which are already, and Starlink also has got added now. Okay, so they are, when you have a, like now if you see these two contrasting requirements in LEO broadband satellites, what the service providers are doing is they are making satellite smaller and have a ground terminal which is slightly bigger in size. Okay, whereas for mobile connectivity, Blue Walker kind of satellite, they have gone for 64 meter square antenna in a space, and the terminal device is very small. So this is the kind of technical, like, what you call it is, if I can call it, the disruptive technology which is being realized now. So this is just kind of what you call it is demonstration. I already told you the antenna is 64 meter square, and they are planning to have maximum 200, but they are right now they are planning only 140 or 135 satellites constellation, and maybe next month one satellite from their Blue Walker series will be launched from India only. Okay, through NSIL, ISRO is going to launch this satellite. So this is another. Already we discussed 5G and 6G. The role already Brahmjit ji has discussed about it. That now the goal of 5G and 6G is to provide continuity, ubiquity, and scalability. So data everywhere at a higher speed. Now it cannot be possible without having a non-terrestrial network segment. I'll take 1 minute to explain you that there was a greater need. Right now, people have gone from L band to C band, utilizing the C band, and now K band is proposed. So if you go on using a higher frequency band for terrestrial communication, the moment you go for higher frequency band, the beam size becomes narrow. So this cell size is gradually going to shrink. Reason being that is, per kilometer or per 100 meter, the number of users you are going to serve is more. The data which you need to provide, connectivity you need to provide, the amount of data connectivity you need to provide is going to increase significantly. And to meet that, it's no matter how much frequency reuse you do, it is going to create a infrastructure burden. So what a city today is covered in, say, using 5 BTS, probably 50 BTSs will be required. So it may not be commercially viable for all the satellite operators to cover the remotest area with the same kind of connectivity or same kind of infrastructure to provide the service, ubiquitous service. So what is the alternative? At the same time, just to give you an example, another example, just to put the perspective. Suppose your city is hosting a World Cup final match. Millions of people are watching that. There is a non-linear broadcast which is now being very popular. Linear broadcast like DTH is no longer popular. People want everything on demand as and when they require. So it is one person with specific broadcasts are being done. So suppose one sports event is going on and that needs to be broadcasted to 1 million users simultaneously. Assume that how much load it will create on the terrestrial infrastructure. So there is a provision in 6G where such things which are to be sent to as a multicast or as a broadcast, that can be offloaded to non-terrestrial network segment, and that's how that NTN becomes very important in a 5G and 6G network. So So there is a NTN also, like no, has got limitations that you talk about the delay. So there is cell tower, there is a high altitude platform, there is a LEO satellite, MEO and GEO. So for different kind of distinctive applications, different kind of NTN elements will be required. So it is going to be a kind of good amalgamation of all the technologies which is going to serve you in future by like no a single platform called 6G communications. So now, having discussed all this, we discussed in the LEO high throughput satellite that like no, the traffic routing has to happen. If the latency has to be minimized or optimized, this is going to put a requirement on inter-satellite link. Okay, so all these LEO satellites, and if you talk about the autonomy, if you talk about the optimizing the latency and the visibility duration, if you want to, if for that matter, security, if you want to address, then in that case you require inter-satellite link. And inter-satellite links are of two types. One is the RF inter-satellite links and another is the optical. Nowadays, very popular is the optical satellite links. So if you see on the right side, the European data relay satellite systems. So basically two LEO satellites, they are able to share data among each other using an optical link through a EDRSS satellite. Or even if a LEO satellite which is capturing a particular region, imaging a particular region, which is out of the visibility of a ground station on the other part of the world, using these kind of data relay satellite and optical link, you will be able to downlink the data in real time. So the data relay satellite systems, inter-satellite links, these are going to be one of the, like, these are the future where we have to do cluster formations. Like, no, this is what we call it is tandem SAR. Like, no, tandem SAR is one of the example of cluster formation flying. So two synthetic aperture radars fly at 100 meter to 1 kilometer distance, and they keep on sharing information in order to achieve the maximum resolution or create a 3D picture of a particular area in microwave domain. So that is something which is the future of this. So this is already we discussed that there is a RF ISL and there is a optical ISL. Wherever the size of the ISL element is going to be minimized or the data rate requirements are going to be large, you require optical ISL. There is no escape from there. So to summarize that even in the satellite communication, which we have talked about as space-based communication, these are the broad domain where AI and ML has already percolated. And each one of them, you talk about interference detection and mitigation, AI ML techniques are there. So they are able to determine. In fact, if you know that there are two signals, there are only one signal, and if you know somehow the statistics of that signal or a statistical property of that signal, you can mitigate that interference by using AI/ML techniques, provided they are deterministic in nature. Similarly, signal identification and classification. This I will again touch towards the end of the presentation, but there are like no, say blind demodulation. There is a lot of surveillance requirement which is going to come, and you want to know whether the signals which are being received or being communicated from one place to another, whether which type of modulation, which type of coding is there, whether there is a communication ongoing or whether it is just a signal to a spoof us. So all that can be done using AI/ML techniques. We have done one of the project has been done, in fact by a part of it has been done by NIT Kurukshetra itself. We have extended that project scope. We'll talk about it subsequently. So there are, you must have all have heard that there is a Chinese vessels which has parked in Sri Lankan waters. There is a big ship which was parked there that has got a 7 to 9 big 11 meter or 9 meter kind of antenna system on board. They are all for surveillance purpose. And if you will go deep, take a deep dive into it, all those signal identification and classifications are being done using the historical data and using the AI/ML techniques. So we can discuss on each of these topics, whichever is of your interest. So that can always be discussed, and I have not gone into the details of each of these problems, identifying problems. So beam hopping pattern, that also is intelligently being done nowadays to avoid that your signal being intercepted by somebody. So there is another aspect is satellite based IoT. Wherever you want to collect some in situ data using a low power element. So there are two types. One is the direct to satellite. So that is still direct to satellite IoT systems, the power requirement is increasing, or otherwise you have to have a geo satellite which has got a very large aperture. Right now we have gone ahead and we have done with a geo satellite we have, which has got a 6-meter antenna in a space. With that, we require a transmitter, which is like kind of 1 watt of power transmission. So if you cannot afford that kind of power, then in that case, you need to go for a very low power IoT sensors, and there is a data aggregator which is put in place. And that data aggregator in turn communicates with the satellite and get connected to the ground station. So these are two different ways of implementing satellite-based IoT. Now, India is also planning to have a 18-meter antenna in space. US already has got 24-meter antenna in space. Ligado is one of the system which has it. So they are the key enabler for IoT based communication. We'll touch about one example. We'll touch toward the end. I'll quickly try to cover that navigation scenario. This is the global navigation satellite system, GPS, GLONASS, Galileo, Compass. Now BDU has also gone global, GNSS, and RNSS, regional navigation satellite system, Navig, QZSS are the regional navigation systems. And all these while these global navigation systems are being used by people, they want to have a sure about the integrity of the signals which are being received. So they have their SBAS system, satellite based augmentation system, which actually increases the availability and talks about the integrity. So VAS, IGNOS, Gagan and MSAS. I think Gagan I already spoke about it. So they have a reference stations put in place, which is already surveyed location, and using a satellite signal, they in the real time they try to determine their position. And since it is a surveyed location, they know their exact location. So from their errors, they calculate those errors in their position which they are able to receive and transmit to a master station. And such multiple reference stations are put in place. The central station gets these errors from different locations, that what are the error they are facing, using which satellite data they are determining their position. And then they use the AML technique to figure out which satellite is not transmitting the correct signal. And then they rebroadcast that information to all the receivers, saying that don't use the signal coming from this satellite. This satellite is malfunctioning at this point of time. So that's how the rest of the satellite data is ensured that their integrity is ascertained, and that's how they're able to determine accurate positions. So this is how it works. This is a standard positioning system which we have today in L5 and S. Very soon we are going to have it in L1 band also. India is going to launch these services in L1 band. These are some of the old receivers which we have developed. Again, many of the signal processing algorithms which were core signal processing based are now gradually inside these receivers are being converted, or the AIML techniques are being explored for the ease of implementation. Okay, many of the places we find that the signal processing requires a complex hardware architecture, whereas the AIML techniques or engines are very much portable on a smaller platforms. So we are exploring many of the signal processing algorithms to be changed into AIML based algorithms. So these are this is just to show the block diagram of a navigation receiver. I'm happy to share that these are some commercially available, but we have built our own navigation receiver also, our own ASIC chipsets with a 28 nanometer, which has already come, and it has come out very nicely. It supports more than 100 tracking channel in L1, L5 and S band, and it has got a dual core processor inside. Very good for a handheld system. Anybody who wants to explore this, to use it, feel free to reach out to us. We will help you, and this is something which is available now. We also support for academia NAVIC and GNSS simulator. So those, like, for everything you cannot go in field and do the testing. If you want to build a signal processing algorithm for your receiver, so this simulator allows you to add different impairments and generate a real-time, like, multi-channel NAVIC signals or GNSS signals, which you can utilize to test some of your algorithms. So this is a very good 65 channel tri-band, like, simulator which we have developed, which is very low cost. So any one of you which you are interested, you can always reach out and get this technology and then utilize it for building these systems. So way forward is, as we already told, that we are going to implement NAVIC in L1 frequency. The reason being that is all your mobile phones and everything, majority of the operators provide the front end which is caters to L1 band. India was earlier given L5. We were not allowed to operate on L1 band. However, now with a better, what you call it, is the signal structure and a better waveform, we have proven that our existence at L1 band will not cause disturbance to any other navigation system operator, and that's how we have been able to obtain the approval to launch our services in L1 band. And already one satellite has gone with L1 and L5, and very soon we are going to have our services in L1 band. So this will help us to proliferate in a very fast way. So even all your mobile phones will have NAVIC signals very fast. So we are approaching twofold. One is we are trying to get the front end changed to L5, support L5, and at the same time we are trying to build our constellation in L1 frequency also. These are some of the technology which I have just listed for your benefit, that some of you which you want to work can always figure out. Real-time kinematics or continuously operating reference receiver. Basically, RTK is a kind of technology wherein you have a fixed base station and there are rover station. Base stations keeps on calculating the errors which are there, which actually uses primarily a carrier-based measurement, and they quantify the different errors which are present in navigation signal, and they broadcast those corrections to rover stations, which implement that corrections into their solution and able to achieve a centimeter kind of level of accuracy. So this is RTK. Same thing actually in RTK. Either you can have a RF link directly between base and rover, or another way is use a coarse kind of solution, continuously operating reference receiver, which actually use a IP network to transfer this kind of corrections. So these are like operational systems which are already in place, and depending on kind of applications in agriculture and surveying, these RTK receivers are being used. Similarly, precise point positioning, there also these systems. We have recently come up with dual frequency multi constellation Gagan for Indian Railways, where we want to identify between the two tracks, okay, to do a collision avoidance or to do a in-band signaling. Basically, you all must have heard that Kavach. Kavach is anti-collision system actually has been put in place to simplify the whole architecture. We have proposed this DFMC Gagan receiver. Once implemented, this will reduce the complexity of this Kavach lot, and this will help us in kind of doing the what you call it is the collision avoidance system. Implementation of that very simple. NAVIC messaging service. Navigation systems are, since it is homegrown, in all the navigation signal structure, we have kept one field for messaging, which we utilize to do an emergency broadcast for fishermen, for potential fishing zone or tsunami or cyclone alert. So that has been utilized for search and rescue also. These are some of the other receivers, like other upcoming developments where we are trying to do a message authentication, so that we are not getting, our systems are not getting spoofed, primarily for strategic services. A space service volume, when you go to a space, you're how to navigate in a space. So that is also another challenge. So we have made a specific receiver which works on very low signal and have very high acquisition and tracking sensitivity. So that is a space volume receivers. One of such receivers has already been flown. Inter-satellite links between navigation receivers also has been proposed, Primarily because right now if you see there is an onboard clock is there, atomic clock is there, and we always upload the satellite, we do the ranging and upload the correct satellite ephemeris for all these navigation satellites. Suppose that if we lose the connectivity of the ground becomes absent for some time, these are inherently going to introduce error into the systems. So if we have an inter-satellite link among these NAVIC signals, that kind of dependency can be reduced significantly, and the system will be more reliable and integrity can be ensured. So that we are going to introduce that. Ubiquitous positioning is one of the systems which we already discussed. These are some of the long-term goals. On lunar, people are trying to go to lunar surface. So there, how to navigate on lunar surface. So there is a lunar PNT is something which is we are planning now. There is a global effort going on. India is also participating to use that. Second long-term goal is we are going to have a LEO constellation. LEO broadband satellites are there. Can we utilize these broadband signals to determine our position effectively without going for constellation? So that is something which is going to be the next generation thing. And underwater navigation is another third aspect. These are all very specific domains which we can discuss depending on interest. Resilient PNT is anyhow is required for a strategic purpose. I'll skip it from here, but I must tell you that all these systems has got a I started with saying that satellite communication and navigation is all pervasive. I would say AI and ML is going to be all pervasive in next generation. So it is going to be in every aspect of this. This is something which we are working on, pseudolight on lunar PNT. So basically on lunar surface, you may not have satellites visible. So we can have certain poles erected or local transmitters erected, which will act as a satellite. So they will try. So that's how we you recently must have seen that RLV, that reusable launch vehicle. So the landing of RLV has happened. There what we have done is on the runway, we have placed these poles, erected poles, and put a transmitters which mimics the satellite, and they help into particular area for any of the receivers to determine their precise position and navigate. So similarly, there will be poles erected on lunar surface which will mimic satellite, and the rovers will get signal from all these poles. They will be mimicking as a satellite, and for such poles, if signals are being received by rover, they will be able to determine their position. So such concepts are in a discussion now, and we are very soon we are going to have Doppler based LEO PNT. Already discussed that LEO broadband satellites are going to be those signals are going to be utilized to determine the position. Satellite based IoT, what we did is I already discussed that we have made a portable, not portable, basically a handheld satellite radio, which actually uses our 6-meter antenna in space. So that radio we have utilized, that radio has got a built-in Bluetooth connectivity. And if you see on the left-hand side, one fellow is having a wearable sensor or wearable watch nowadays. In that watch, you will find that Bluetooth is now built in. So we made an Android app which actually from this wearable sensor, it maintains the body heart rate, blood pressure, and all those data. And through Bluetooth, it transferred to the radio which is in his hand. And that radio signals are being transferred to a remote location. So a mountaineering person who is going for mountaineering, he is wearing this watch and keeping the radio in. One of his teammates is having this radio. So all of them are connected to that, and their body temperature, pressure, and heart rates are being monitored. In fact, on the mobile phones also, there is a Android application which acts as a chat box. So using the satellite radio, even the mobiles get connected to that, the mobile phone gets connected to that, and you do chatting also. So chatting, body physical parameters, monitoring, and all that can be done remotely. This was demonstrated by us, and as I said, is with the next generation satellite, we wish to make it a practical system which could be proliferated. Now, this is some of the synergetic navigation and communication applications. Indian Railways today has got a communication system mounted on more than 10,000 plus locomotives, 10,500 locomotives. So all those locomotives is fitted with a radio which has got a satellite connectivity along with two terrestrial modems. So what happens is whenever there is a visibility loss because of the shed, suppose a train enters into a railway shed, loco shed, then in that case, because of the set satellite visibility loss, the GPRS provides that connectivity or wherever like now. So that's how the availability of the system has increased beyond 95% or rather 99% to be very frank. And this set, the train locomotive information every 30 seconds is being received at the central location, which is being used for control office automation, charting basically. So between two railway stations or junctions, there are number of trains which are coming, which will go first, which will go second. That charting is being done automatically using these positions of the satellite. More than 27 million position updates are being received through this network on a daily basis. And Indian Railway has automated more than 75% of this control of automation charting. So this is one of the applications which is already there. Similarly, our passenger aircraft of a strategic users, now every 4 seconds they are being tracked through a SATCOM network, NAVIC enabled SATCOM network. And on the left hand side, you are seeing that there is a NAVIC messaging receiver where all the potential phishing informations which are being derived using the remote sensing data and in situ data, they are being disseminated to all the users using this NAVIC messaging receiver. So these are some of the systems. Person tracker is another system which is used for personal tracking on the remote or border areas. So these systems are operational systems. One of these systems which already I think was discussed in the beginning, that vessel communication support system for monitoring, control and surveillance. So this is already across 9 states and 4 union territories, has been operational on more than 50,000 boats are already being tracked with a target of 1 lakh by this year end. And I'm going to list out this network. Just remember that it does a position reporting every 15 minutes and it supports two-way voice communication. Okay. Nowadays, one of the thing which a requirement which has come up is the supply chain management using this SATCOM network. So what happens is most of you might not be aware that when fisherman goes for fishing in deep sea, he gets a different kind of fishes. There are variety of fish types. There is a tuna, hilsa, and different category of fish. And there are certain fish categories which are treated as gold mine. Their size and quality depending on the length of fish, the breadth of fish. So, and these are raw fish, right? So when they go for fishing deep into ocean, they may take 3 or 4 days to come back to shore station. So there is a need that before the moment they get the catchment, they wanted to communicate that they have got this type of fish or this category of fish and this much quantity. Okay, so that by the time they reach to the shore station, there is a buyer which is already ready, or there is a container or a shipment which is already ready, such that time to from the catchment to the user, it could be sent in a smallest period of time. The sooner you are able to send, the more fresh the fish is, the higher the pricing is. So everything turns into revenue. And if I can quote you that it's a $1 billion industry. It's not $1 million, it's a $1 billion industry. So there is a need for technologists to provide a solution that how to inform the catchment before they arrive to shore station, such that that information is broadcasted to market, it is auctioned, and a proper buyer at a suitable price is ready to take the catch once the boat or the ship reaches the shore station. To do that, we have built an Android app, okay, through which they can. Before I go to that, let me complete it, that catchment part, then I'll come here. So this is the problem statement. I hope this is visible to all of you. So we have made an Android app in which we have given a page through which they are able to select, okay, I have got tuna fish, I have got 20 kg of fish, and I have got of this category of fish. And category is defined based on size, weight, and the size and weight. Now there is a need. Can we have and this fisherman has to enter it manually. They find it lot of problem. There are many of the fishermen which go for fishing is not literate, so they find it very difficult. So there is a need to build a problem, basically a neural network where you should be, if the suppose fisherman is asked to take 2 or 3 photographs from 2 or 3 different angles, and using that photograph and with a data set of the past, can we identify which species of fishes are present in that, what is going to be the quality of that, quality indicator of that fish, what is going to be the estimated weight and volume of that roughly, and can we do a geotagging so that at least the next time that person can come and reach over there. So there are a lot of technological things based on AI ML people are trying to do. This is one of the set of problems which I have listed here. Likewise, there are many such problems which are there. This is what we are giving it for this year Smart India Hackathon. Any of you can promote your students to participate. It's already up on the website, and you can attempt to solve this problem. Okay, I will list some more problems, but I'm just trying to drive that while doing this there are many such problems which has got a good solution hidden in that AIML techniques. Okay, coming back to the core part of the element, this network is being used for cyclone warning. So we are able to, like IMD, the moment it generates a cyclone warning, we are sending that information, and what is going to be the path of the cyclone that we are giving. Nowadays there are AIML based techniques for cloud burst detection. We call it nowcasting. In nowcasting there are AIML techniques which are being utilized. So we use that nowcasting data also can be broadcasted. If any fisherman is crossing international boundary, so we generate international boundary crossing alerts. Historical tracking you can do where the ship has gone. This is some of the app which we have given the photograph of that. If a fisherman faces any boat is drowning, fire on board, he can press that emergency button and help will be provided to them. Similarly, weather alerts are being disseminated to them. All that informations are made available. This is just to catch the highlight of that particular project. More than 50 MSME has got benefited, 1,000+ jobs are created. More than 50,000 devices are already in field, manufactured and given. And this is this is the overall benefit this project has brought in. We can discuss it subsequently as time permits. This is another problem which we are giving. I think Professor Brahmjit also talked about use of a Gaganyaan. I have deliberately, because of the time constraint, I have not gone into the network detail, but just try to list. Can you have the astronauts, they go for in a space, and there is a requirement that they may get tired or sometimes they do not respond to call from the ground. Can we have a AI assistant which does the psychological and physical well-being of astronaut? They are able to determine by remote, like camera monitoring. So there is a in-cabin camera is there which continuously takes the photograph, and if they are too tired, they can generate alarms. They can generate alarms. They can inform the ground segment, ground station for necessary actions. Very soon we are going to have Bharatiya Antariksha Station. There also there are going to be so many crew members are going to be there. So this is one of the tool which can be utilized for this. Similarly, AI based smart multi-mode receivers, I'll also touch upon that. I think I have kept it. This is deep learning based receivers are also going to be the next generation thing, wherein the conventional communication receivers are likely to replace the deep learning based receivers. So any one of these domains you can take it up and then do it. For AIML, this is one thing which I wanted to again highlight. For maritime domain, there is a Mumbai attack happened now. After that, we were asked to work on to strengthen the maritime security. So how to detect the dark targets which are there in ocean? So there are ships which have got more than 300 gross ton. They carry something called automatic identification systems. Basically, it's a line of sight communication system which keeps on transmitting its position depending on the location from the source station. It can transmit every 6 seconds to 2 minutes. So that position comes to a ground station. There is a greater need of, like, since they are only, their coverage is limited to 20 nautical mile from the source station, there is a effort now being put to a space-based AIS. So that at least when they are beyond 20 nautical mile from the source station, their position can be received by a satellite and relayed to a ground station, so that we know their locations. Similarly, already we discussed about the VCS. So all these locations, so we know that each of these boats or ships which are in oceanic region has got a radio beacon. They keep on reporting their position. So we know their position, right? The latitude, longitude. Suppose there is an optical satellite with an optical sensor or a microwave sensor, which takes an image of that oceanic region, do a object identification. If you see on the right hand side bottom, they have done an object identification. They have figured out ships. Okay. These ships are visible. Now, if we know the radio beacon, we can fuse the data, radio beacon data, and the objects which are not transmitting anything, they are labeled as dark targets, and only their movements are being monitored. Now, here to identify these dark targets and movement and predict their movement, their AI/ML based techniques are being utilized. Association of the radio beacon with this objects which are identified in an optical image, because they are going to differ in time. The radio signals which is available to you for position determination may be old by 30 minutes, because when the time when it was imaging was done, at that time exact position was not known. So maybe the position was known 30 minutes prior. Doing this association also, AI/ML techniques are being utilized very effectively. So some of you can look at those problems also. Communication intelligence generation. Here I think Professor Brahmjit, I'm not too sure whether he discussed about it, but all the security agencies of different country are, they want these kind of systems which are autonomously listening to all the communications going on different frequency bands. So if you see here on the right hand side, the block diagram, they have multiple antennas which converts a Ku band signal, Ka band signal, C band signal to L band signal, and they try to do a spectrum recording and a spectral analysis to figure out where all communication is going on, where all signal energy is present. And once they know the location of the signal, where it is present, they try to identify the bandwidth of that particular signal, and based on that, utilizing all this information, they go and do a automatic modulation recognition, that which kind of signal modulation technique is being utilized on those communication. Once they know, they try to identify the symbol rate and bandwidth. Bandwidth is anyhow known. Based on the modulation scheme, they try to figure out the symbol rate is known to them. They try to find out which kind of FECs are being utilized, which kind of a scrambler polynomial, and then try to autonomously decode. And after decoding, they employ many techniques to identify whether the communication is going on is audio, whether it is a video, or whether it is a data, which data, whether it is a web browsing data or whatever. So to do this, there are signal processing techniques and there are deep learning based classification approach. NIT Kurukshetra was given this task, and they have done it for one class of signals, and we request they are anyhow taking it up to the hardware level and to the next level. This has been done only for one subclass. This is a never-ending problem because the class is increasing. New and newer modulation schemes, new and new FEC schemes, newer and newer polynomials of scrambling polynomials are being utilized. So this problem can be extended. Similarly, a data-driven approach to identify whether it is voice, video, and data, and doing the cipher analysis, that also is something which can be done using AI/ML techniques. So this is something which I discussed already now. which we have done, and we have identified and we have done it. So these are some of the things which you can do. As I come to the closer, I just wanted to say that we have a vision to harness this space technology not only for societal now, but for science and strategic application through innovative and self-reliant communication, navigation, and Earth observation payloads and human-centric systems. And when I say this cannot be achieved unless we rededicate ourselves in utilizing the new concepts of AI and ML in solving some of these problems which we discussed during this last, I think, 55 minutes of my presentation. So I have not gone into the details of problem. I've just tried to introduce the different areas. Any one of you have got any a specific interest area, please reach out to us, and we will be happy to interact with you. We will help you to formulate a particular problem. And I'm sure you are going to have a lot of discussions in the coming days, which will help you to kind of zero down on the core, like how the AI/ML techniques are there, how LSTM works, how those big signal models are being used, how CNN works, how RNN works, and all that. I'm not the right person to talk about all that, but all I can tell you, each of these technology has got an application when it comes to the satellite communication and navigation. Maybe it has got a wider use in remote sensing application, which we'll touch upon at some other point of time. Thank you for your patient listening. Any questions if you have, I'll be happy to answer. Shall I stop sharing?
Yes, sir. You can stop sharing. Anyone from the audience, if you have any questions or you want to interact with Dr. Chandra Prakash, so you are welcome. Okay, I think, sir, there is no question, but
It's
it was
9:30.
it's already
So people must be tired.
9:30. So thank you so much, sir, for taking the time to join us for delivering such an insightful and inspiring talk. Your experiences at ISRO and your perspectives on satellite technology and innovations has truly enriched our understanding. So we deeply appreciate the clarity, depth, and enthusiasm with which you shared the content and your knowledge. On behalf of the organizing committee and all the participants, I sincerely thank you for your valuable contribution and for inspiring everyone here to continue exploring and innovating. Thank you once again for being with us, sir.
Thank
Sir,
you.
I think one question is there from in the chat box. They are not, I don't know, they are not talking. So, what are the front end and back end technologies which we use to develop such applications at college level?
What are the front end and back end technologies which we can use to develop such
Such
applications at
at
college level?
college level. So, this is a chat box.
You only need to have a proper formulation, and a part of problem you need to understand it in terms of the input and output. We with our experience, we understand that uh, it is very difficult to build infrastructure or to create infrastructure at that level for getting the data from the any of the front end or back end, whatever you call it. We always prefer that academia with the simulation tools which is available to you, like MATLAB, HFSS, and all that. If you talk about the ASIC building, different tools are there. Um, there are Keysight, there are so many tools. There are system design studies tools are there. Those only using those tools you can utilize, do the problem formulation and work at your college level. If you require any specific data sets, we will be more than happy to provide you. Okay, there is nothing called the front end and back end technologies, because we try to formulate. We understand the academia, we do not want them to recreate the infrastructure which we have at our end. So You just need to pick up a portion of problem which you can solve at your end. Yeah, if you want to take it up problems like now, you want to build a chipset, then you require a tool. If you want to build a modem, then you require a hardware and software. But if you want to work on algorithms, you don't require such things. Those test bench, data sets, all will be provided by us.
Thank you, sir. Sir, there's another question that they are asking how we can connect to you directly. So I think your email ID is there on the website, so they can connect you on the email ID, or if there's
They can,
another
for the
source.
benefit, I'll write it here also. No
Right,
problem.
sir, right.
They can reach out based on their interest. So we'll try to see how best we can help you. Yeah.
Yes, now I think you have got the email ID, so you can connect to him directly, not an issue. Okay, I think we should end this session. Thank you so much, sir, for your time.
Thank you everyone. Yeah, thank you everyone. Thank you.
Okay, with this, we are ending today's session. So we'll meet again tomorrow at 6 p.m. with the same link. And tomorrow's expert talk is by Dr. Amit Kumar from IIT Jodhpur. And then we have expert talk from Dr. Puneet Kumar Jain, NIT Rourkela. So both the academicians tomorrow. Okay, good night, everyone.